Welcome back to the Godot platformer. In this part, we're going to add the shooting mechanic to the player, which is going to involve two major things. Number one, we have actual player animations. And number two, we have a gun that can shoot bullets. To get started, I want to work inside of the player. And at the moment, we don't have any animations. That is because for the player scene, we have a sprite 2D for the graphics. This I don't want to use anymore. So let's delete the sprite 2D. And instead, I want to have an animated sprite 2D. Now we have to figure out how to work with an animated sprite 2D. For that, you want to look at the inspector. Under animation, we have a couple of sprite frames. At the moment, this one is empty. But if you click on empty and add sprite frames and click on that again, we now have a sprite frames editor. In there, you can set a couple of animations. I want to have an idle animation. Then I can create another animation, which is going to be the walk animation. And finally, I want to have one more animation, which will be jump. Once we have that, on the right, we can assign a couple of images to each of these animations. For that, we will need to go to the player graphics, and in there we have basics and gun. And honestly, not that many graphics. The way the system is going to work. For example, for idle, we only have this one graphic, which is totally fine for an animated sprite, but it means that while we do have an animation, it's not really visible. We basically keep on playing this one frame continuously. So in practice, we have a static frame. However, then for the walk animation, I want to have idle and afterwards the walk animation. If I play that one with the play button, we're getting a walk animation. So that one is working pretty well. Although for now, I want to stop the animation. Finally, we will need a jump frame, and this we're getting from the walk frame. Now, once we have all of that, we have a basic animation for each of the states of the player. We just have to figure out how to use it, because if I run the game now, nothing is going to happen, and that wasn't supposed to happen. Let's try this again. If I now walk around, the player is not animating. For that, we have to work inside of the code. And let me clean all of this one up and make the inspector and the node tree a bit smaller. That way we can focus on the code. To organize all of this, I want to create another function. Let's call it getAnimation. Essentially in there, I want to create a variable called animation, which by default will always be idle. And this animation we can use inside of the animated sprite 2D to update the current animation that we have. So this value should be the value we are setting to the animation, which means at the moment we are always setting the animation to idle. Or rather, we would be if we called this function, which we really should do. If I now run all of this again, we always have the idle frame. However, we could change this and set this to, for example, walk. If I now run all of this, we are getting another frame, but no animation. That is because inside of sprite frames, you want to activate autoplay on load. Now in our case, we want to autoplay idle, which is our start state. But once you have this activated, you are always playing whatever animation you have. So for example, inside of walk, we would be playing through this animation. Let's try. And now we are playing the walk animation. So that's a pretty good start. Although not exactly what we want to do. Instead, I first of all want to check if not is on floor. If that is the case, I want to update the animation and set it to jump, which means now we should already have two states. We are either walking, or if I jump, we have a jump state. So that's a pretty good improvement. However, next up, I also want to check if direction.x is, let's say, different from 0. If that is the case, the animation state should be walk, although the default state should be idle. I can now run all of this again, and by default, the player is idle. But if we walk around, we have a run animation. And if I jump, we get a jump frame. So that is definitely an improvement. However, the issue we have right now is that the player is always facing to the right, even if we are moving left. Not ideal, but fixable. The way I approach that one is all the way at the top. I want to create another variable that I called facing right, which is going to be another Boolean value that by default is true. Because by default, the player is indeed facing right. But once the player is moving left, we want to set this value to false, which I'm going to do in another function. Let's do it right before get animation. I want to have another function get facing direction. The only thing that we want to check in here is if direction x is different from 0. Because we only really want to check all of this if we are moving. And if that is the case, I want to update facing right to direction.x greater or equal to 0. And let me explain what's going on in here. Imagine this is our player, and by default, the player is looking to the right. That is the default value. However, once we start moving left, we want the player facing in that direction as well. For which we have this line. If we are moving left, direction x is going to be -1, which is not greater or equal to 0, which means the return value for all of this will be false. And if facing right is false, we know we are facing left. There are only two options. However, there's a pretty major problem. Imagine once again, we are moving to the left, so we are facing to the left because of this line. But then we stop moving and our direction.x will become 0. And 0 is going to be greater or equal to 0, which means the return value for this one will be true. And as a consequence, we only face left if we are moving left, but once we stop moving, we are facing right again. That, however, we are preventing with this line, where we only updating facing right if the player is moving. Or in other words, we prevent direction.x to ever become 0. That way we check if the value is either greater than or smaller than 0. But 0 itself will never be the case, simply because we check if the value is different from 0 in the first place. But anyway, first of all, we want to call, before we get the animation, get facing direction. And this right now is not going to do anything, so I can still move around, the animation works, but nothing has changed. However, what we are now able to do inside of get animation, we want to basically flip this animated sprite 2D if facing right is false. And for that, if you have the animated sprite selected and you look at offset, there we have flip H and flip V. If you hover over them, you can see flip H. This is what we want to call. So flip H is going to be facing right. Although this is not going to work exactly yet. Let me try. And now we are always facing in exactly the wrong direction. Essentially, by default, our character is facing to the right, so we only want it to face to the left if we are not facing right. Let's try this one now. And this is working much better. I can still jump, and we are looking in the right direction. A significant improvement. That's a really good start, but we are still not entirely done with the animations, because at the moment we only have the basic frames. There is no gun at all. For that, we want to work more inside of the sprite frames. And I think the best way to approach that is to create 3 more animations. We have jump underscore gun, then we have idle underscore gun, and finally we have walk underscore gun. For all 3 of those, we have basically the same frames, except now we have a gun. Meaning for idle gun, we have the idle gun image. For jump gun, we have the walk image. And for walk gun, we have both. So idle and walk. After we have that, back inside of the code of the player, I want to create one more parameter. Let's call this one has underscore gun. Once again, this will be a Boolean value that by default can for now be true. Basically now, we want to check all of these animations, but then also add another state if the player has a gun. Although that we can make quite a bit easier, because all we have to do to get to the right state is have the state of the basic frames and then add underscore gun, which is really easily done. All we want to check is if as gun is the case, and then we want to get our current animation and then add underscore gun to it. I can now run all of this again, and all of the other animations still work just fine. We can jump, we can idle, and we can walk. So I am very happy with that. Looks great. With that, we are also finishing the get animation function, and also we don't need gravity or facing direction anymore. All of these functions are pretty much done. So next up, we have to actually shoot bullets, and that system is going to become a bit more complex. But essentially, I want to create another scene, which is going to be an area 2D node that we can rename right away to bullet. Let's save all of that as bullet.tscn. And then if I show the editor, we basically want to do the same thing we have done for the B and the player, meaning we want to have a sprite 2D and we want to have a collision shape 2D. For the sprite 2D, I want to go to the bullets, and there we have a bullet, which is going to be the texture. So let's drag it in there, and that looks all right. For the collision shape, I want to have, I guess we can go with a rectangle shape for this one, and then make it fit to something like that. That looks all right. And now, I want to work inside of the player. And if the player from inside of get input gets the input to shoot, then I want to create one instance of the bullet inside of the level. That is important because later on we are checking the collisions between the bullets and all of the enemies inside of the level. So the bullets need to be in the scene. They couldn't just be inside of the player. Hence, we have to get information from the player to the level scene. And the best way of doing that is via a custom signal. The way that is going to work, all the way at the top, I want to create a signal that I'm going to call shoot. This signal is going to have a couple of arguments, 3 in total actually. Although for now, I simply want to have the position, which is going to be a vector 2. Once we have that, we can go back to the 2D scene, and in the level, if you click on the player and go to node in the inspector, we have a custom signal, shoot, that we have just created. This we want to trigger and run some code inside of the level. For that, first of all, the level scene is going to need a script, which we can add very easily. And after we have that, with the player selected, I want to connect the shoot signal to this script. And just to make sure that this is working, I want to print shoot from player. Although at the moment, this is not going to trigger because inside of the player, we have a signal, but we are never triggering the signal. For that, we have to go into the get input function. And there, at the moment, we are simply printing shoot. What we want to do instead is get the shoot signal and then emit it with a certain position. At the moment, this could simply be the global position of the player itself. As a matter of fact, inside of the level, besides printing shoot from player, I also want to print the position that we are getting. And now, if I run all of this, I can press space, and we get shoot from player in a position. If I go further to the left, we are getting another position. So that looks pretty good. This information we now want to use to create one bullet, or rather one instance of the bullet inside of the level. Now to keep all of this organized, I want to create another node 2D inside of the level that I will call bullets. To this node, we're going to attach all of the bullets that we are generating inside of this function. Now, to create nodes via code, we need 3 steps essentially. First of all, we have to preload the scene, which can be a constant. I want to have a bullet scene. The data type for this one is going to be a packed scene. And then the value is going to be preload with the file path to the bullet.tscn. That way, we essentially have a blueprint for one instance of the scene. And that we want to create inside of the function. Also, I want to store all of that inside of a variable. Let's call it bullet. Now, to turn this blueprint into an actual scene, we need this scene, or rather the blueprint, so bullet scene, and then run the instantiate method. After that, we have one instance of the scene. And this is going to work, but at the moment wouldn't do anything because we didn't attach this new node to this node tree. And let me add a bit more space in there so you can see the player. So the last thing we need is the add underscore child function, which is going to add a node as a child to the current selected node, which in our case is the level. There, we want to have the bullet. Now with that, something is going to work. I can run the game and press space, although on the surface, nothing is going to happen. However, if you now go to remote in the editor and expand game and level, there you can see we have a whole bunch of bullets. And if I go back to the level and I press space, we keep on adding more of these instances. So at the very least, we are getting something. Now, the issue in our case is when we are adding a new bullet, we are adding the bullet at position 0 and 0, meaning all the way up there, which is a position the player can never reach. Although, just to demonstrate, I can add just a few more tiles. Let me reorganize all of this just a bit. The player can only really jump over one tile at a time. This needs to be a 45-degree hill. Let's say there, 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 and there. Now we can see the origin point. So if I run the game again and I jump all the way to the top left, and while I'm doing that, I keep on pressing space. So we get more and more bullets. And now we can see we have a bullet all the way in the top left. And this is not just one bullet, this is multiple bullets. Meaning, at the very least, this logic is working. But there are two main problems. Number one, this bullet shouldn't be added to the level. It should be added to the bullets node 2D. I simply want to get the bullets node and then call the add child method on that one. That is going to organize our code significantly better. Although we still have the same issue in the game, we always spawn the bullet in the origin point. But that we can fix by setting the bullet position to the position we are getting from the player, which at the moment is going to be the global position of the player. And now if I run all of this, I can press space and we are getting a bullet. So that is working pretty well. However, at the moment, the bullets don't move, which, well, isn't ideal. But that we can fix inside of the bullets. I want to give them a script as well. Can be called bullet.gd. Click on create. And all they really need is an underscore process function with delta. And we basically want to set position.x plus equal, let's say for now, some kind of speed, 300, multiplied with delta. Since process will be called automatically, this should move all of the bullets. If I now press space, we're getting a bullet. Now the issue is the bullet is always moving to the right. Not great. And well, fixing that part is going to be your exercise. So I want you guys to make the bullet move in the right direction. On top of that, you can also give the bullet a start offset from the player. At the moment, if this is our player, the bullet is always starting right in the center of the player. But I think it would be much better if the bullet started somewhere like here. Not necessarily what you have to do, but could be a bit of an extra challenge. But anyway, pause the video now and see how far you get. Inside of the bullet, I want to set a new variable called direction, which can be an integer with a default value of 1. And once again, you don't really have to specify integer, you can simply use double colon and then a 1. This is going to be the direction, and by default, we are going right. To apply all of that, we want to get our speed, currently 300, and multiply it with the direction. And also, don't forget delta. On top of that, before I continue, this 300 should also be stored in a variable that we can also export. So speed for the bullet is going to be an integer of 300, and there should be a var. After that, we can use this speed, and then we are good to go. Although at the moment, this is not going to make a change. The bullet is still moving to the right. To fix that inside of the level, when we are creating the bullet, we have to tell the bullet which direction we are going. And that information we are getting from the player. Essentially, if the player is facing to the right, then the bullet should be moving to the right as well. However, if the player is not facing to the right, then the bullet should be moving left. This facing right, we are going to use a lot. And to get that value into the level, when we are emitting the signal, we also want to emit facing right. And that value is either going to be true or false. Although, as far as the shoot signal is concerned, we are simply getting the direction, which is a Boolean value. After that, we can work inside of the level, because now, besides the position, we also have facing right. This facing right, we now have to turn into a direction, and let's do it in a variable all the way at the top. I want to have var direction. And this value is going to be 1 if facing right it's true. But if it is not true, then I want the value to be -1. Finally, inside of the bullet, I want to update the direction to the direction we have just created, this one. And then I can run all of this again. I can press space. If I'm looking to the right, the bullet is going right. And if I look left, the bullet is going left. Although it's not amazing yet, because the bullet needs to be flipped on the horizontal axis. For that, back inside of the bullet, we basically, on the sprite 2D, want to work with flip H and turn it on if the bullet is moving left. We want to create the func_ready function. Get our sprite 2D and then flip_H. As a reminder, the _ready function will be called as soon as we are adding this node to the scene tree. Or in other words, inside of the level, we are calling the ready function when we are adding the node as a child to the scene tree. We want to set flip H to the direction and then check if this value is smaller than 0. Let's try. And if I now press to the right, this looks good. And if I look left, this is not looking good. And the reason can be a bit intricate. Basically, inside of the level, we are calling the ready function or the _ready function when we are running this line. And then we are checking if we are flipping the sprite 2D or not. However, we only update the direction afterwards, which means when this method is running, direction is always going to be 1. But that we can change. We can update the bullet direction before we are adding it as a child. And now if I run this again, this looks good, and this also looks good. Perfect. And this is a general thing that can be a bit confusing in Godot. You are always calling the _ready function when you're adding a node to the scene tree. Meaning in our case, we always have to set the direction before we are adding it as a child. Only after that do we get the proper direction. The last thing I want to get is a bit of an offset for the starting position. And for that, when I'm setting the starting position of the bullet on the last line, I want to add a vector 2. And there I have to set x and y. Now y for now can simply be 0. But on x, I want to add 16 pixels. If I now run all of this again, the bullets start a bit further to the right. However, this isn't perfect yet, because if the player is facing left, then this system breaks down quite fast. Although that we can fix fairly easily, because this 16 I want to multiply with the direction. That way, it's going to be +16 if we are facing right, or -16 if we are facing left. Let's try that. That looks good, and that also looks good. Cool. The number might be a bit large. Let's try 14. But these are numbers you can play around with. It's reasonably subjective. And I think this video is already getting a bit longer, so let's finish it here. we have made quite a bit of progress.